This is the demo video for project 4 part 1, which is the Twitter API using Akka Remoting. So let me download the project. I have uploaded the project on UFE Learning. So this is a project file. Let me download it. Okay, so this is the folder. So it contains a client.fsx file which has all the functionality related to client and simulator, and the simulator simulates the number of users and their functionality. So, and the second file is server.fsx file which has all the functionality related to server, all the endpoints basically. So I have also included the outputs for different simulations that I ran with this API, and it has one project report as well. So let me give you a quick walkthrough of what server.fsx file has. So basically server.fsx file, as you can see, it is using Akka Remoting, and this is the server. These are the server actors which actually emulate the backend servers, and I run multiple instances of that. So it has all the functionality like register user, login, follow other users, log out, tweeting. So when tweeting happens, basically when any user tweets, then this tweet is sent to all the followers of that particular user, and it is also added to the tweet table of that user. It is also added to the feed table of other users who follow that particular user who is tweeting, and any mentions or hashtags are extracted from the tweet and saved into a table so that later they can be queried if any query is made. Then retweet operation is there. Any user can retweet a given tweet, it gets into its feed. And then we have hashtag query, mention query, and get all users tweets. So this is the server part. Let me show you what the client part has. So this is the client simulator. Basically it is simulating different users using actors, Akka actors. So each Akka actor represents one user, and it performs the user functionality. This is the zip operation distribution function. Basically this is creating zipf distribution initially as instructed in the problem statement, and then the operation starts. So this is the user actor. It has all the actor user parameters like username, password, session time. Session time is basically given duration between a login and logout. So and then it has, so the way the simulation works is first the user registers to the Twitter API. Then once the registration is successful, then it proceeds towards login. Once the login is successful, then it subscribes to other users. It can follow other users. So the session starts once the user logins. Then it can subscribe to other users. It can also tweet, and whatever it gets in form of subscription feed, then it can also retweet that. It can randomly decide whether to retweet or not the tweets that it is getting. And then we have hashtag query, mention query, and get users tweet query status, and all these functionality is there. This is also running using Akka Remoting. You can see this is the Akka Remoting part, and at the end I'm printing all the performance parameters. I'm recording some performance parameters, I'm printing those for each simulation. So let me run the program now. So commands to run the program are in readme.txt file. So let me run the server first. So basically server is running many instances of Akka actors. So I'm running currently 128 Akka actors as servers. This is to emulate in multiple instances of server as it actually happens in real time applications. And I'm choosing 128 because this was the optimum value I got to run this application at its peak, at its best perform, to run it like in the best way. And let me run the client part now. So the client takes one parameter as integer, which to specify number of users. The session time for all users is in this part I have set as default, which is 60 seconds. So after 60 seconds all the users will log out. So let me run it. I'll not run it for 100 because it takes time. Let me take 20. So as you can see on the server side, as of now there is no response, but as you can see, user login successful. So user, first the zip app distribution was prepared, now then users registered. So as you can see, all the users registered successfully, then they logged in successfully, and now users started following other users. We can also see some response on the server side now. So this is the response. I'm not printing much on the server side. I'm printing all the responses that are coming from server on the client side. So once the user logs in, so it starts tweeting and retweeting, everything starts suddenly. So that's why it's taking some time, because the server gets overwhelmed a little bit, but eventually we get the response, so we have to wait for a few seconds. So now we have started getting response, as you can see. So after following, users started tweeting. As you can see, each tweet is a dummy tweet. It has a hashtag and a mention, and so these tweets are happening, and we have hashtag query. We are also running mention query. So for a hashtag art, we've got some response. For hashtag, for mention user 14, whatever tweets mentioned user 14, this is the response for that. So these are hashtag and mention query basically, and still some logins happening, logouts are happening, and users are tweeting again, and so the simulation is running currently. As we can see, many users have started logging out now, and many users are tweeting at the same time. So we have got this response finally. These are the evaluation parameters that I'm printing at the end. So it reprints how many requests were actually made and what was the time taken at each point when all the 20 users were registering, how much time it took to complete all registration requests, how much time it took to complete all login requests. So this is what it prints. So that was the demo. Thank you very much.